Okay, welcome everybody. Welcome to the December meeting. Getting a chat thing out of the way here. So tonight, pull up some hot chocolate or refreshment or whatever you have close. And we're going to have our December Christmas meeting. So I just want to make reference to the fact that the Queen's University, where we will be meeting next month, is situated on the territory of the Haudenosaunee and the Anishinaabe. And we recognize that. And so now for our regular agenda, our YouTube is not working, so we're just got our Zoom going. And just want to remind everybody of our Wednesday night social Zoom time. An email is sent out to the center chat list. So if you're not on the chat list and you want to be, send us a note so we get you hooked up. We are still looking for volunteers to run the Zoom social on Wednesday nights, so give Susan a bit of a break. And Queen's University open house, December 17th at 7 p.m. Now, of course, the weather doesn't look so hot, so I think we'll be okay for nobody on the deck. But if the weather is good, then we will need somebody out on the deck. There is a telescope there in the observatory, along with all of the eyepieces and everything that's needed. And Elena was there last month with Lori. Lori is going to be just coming back from a vacation, so we are not expecting her to show up. Big announcement, of course, is our next meeting will be hybrid and live in room 226 Ellis Hall. Please write that down. It's not the same room we were in before. And we are going to have our Zoom meeting hooked up as well. Our guest speaker will be Scott Young, and he'll be speaking on Dome at Home, astronomy talk shows for the virtual astronomy community, which has really been a great success for Scott. He actually did the lunar eclipse, and we were actually watching him freeze his little hands off when he was running into technical difficulties because the cameras were getting too cold and the scopes were too cold, but he ended up pulling it off anyway. So hopefully we'll see you all there in January, and if not in person, then online. So next I'm going to come up with David Levy is going to give us a poem to kick today's meeting off. Go ahead, David.
Well, thank you so much, Kim. And being here with you is reminding me of the very happy days I spent when I was a master's student at Queen's. It was at Queen's that I discovered the wonderful relationship between the night sky and English poetry that I've really emphasized for the rest of my life. We're now entering the holiday season, and this year will be the first one. It'll be the first one without Wendy for me, and it's really very difficult. But for my poem tonight, I would like to read from Robert Frost. It's a very uplifting poem for me. It's called The Road Not Taken. It kind of describes the path of life that I and a number of us here have taken. Two roads diverged in a yellow wood, and sorry, I could not travel both and be one traveler. Long I stood and looked down one as far as I could, to where it bent in the undergrowth, then took the other as just as fair, and having perhaps the better claim because it was grassy and wanted wear. Who as for that the passing there had warned them really about the same, and both that morning equally lay in leaves no step had trodden back. Oh, I kept the first for another day, yet knowing how way leads on to way, I doubted if I should ever come back. I shall be telling this with a sigh, somewhere ages and ages hence. two roads diverged in a wood. And I took the one less traveled by, and that has made all the difference. Thank you so much, Kim, and back to you. Thank you.
Thank you, David. That was beautiful. Okay, next we have Bruce Elliott, but I don't think he's here yet. And then we had Andrew Godefroy was going to pop in and talk about Regulus. Everybody should have received the link to look at the new Regulus.
Andrew was here and then disappeared, so.
Oh, Andrew was here and disappeared. Okay, he'll be back. Okay, next we'll have John Hurley. You're up with the talk on Leo Enright's telescope.
Hello, everyone. As many of you know, the center has Leo's old 14-inch C14. But just as an aside to start the day, this was my Christmas present to Peggy and myself, a 100 to 400 zoom lens for our camera. And this was the sun today with the new lens and a 2-time converter. Very busy. Okay, so now then, will it let me?
Look at those sunspots. Fantastic.
Yeah, the large group in the south was visible naked eye when you look through the solar filter by itself without any magnification. The journey for now back to the telescope, Leo's scope is eventually going to be living inside this monstrosity that you see on the trailer that I picked up from Kevin and Kim's earlier in the summer. Just a brief overview of where that is at the moment. We had several pieces loaded up into a trailer and a truck, sitting in my backyard upside down. That's the top of my head inside there. We made just laid some patio stones down for the base, so it's something reasonably level. The beginnings of the stuff. Here I'm working on cleaning it up and putting it back together. It's upside down at the moment. And there, after we spent a few hours trying to figure out which pieces go where, we got things on there. The weather stripping that was falling off is sitting there in the foreground on the ground. That is still needs to be changed. So there'll be some more work to do on the dome this spring. My time this summer and fall got greatly reduced when I went back to work at the airport in July, which was supposed to end in beginning of September, and it's been carried forward indefinitely as long as I care to suffer through those hours. But the dome is working fine. It all went together. It's not too bad inside. I do keep some plastic cover over any equipment I'm keeping in there. And that's the dome as of today. And then Leo scope. The reason it is not up and in usable condition at the moment is Leo's was mounted on a pier inside his observatory. And the bits and pieces we managed to collect included the tripod legs, but no interface to go from the wedge to the legs. There's the wedge. And that wedge bolted onto, this went on top of the pier, and that wedge went onto there. And then the old mount, the old forks went on to that. And there's Leo's scope. And this week, I have received in the mail a rail to mount onto the C14. And this will fit onto a tripod that I purchased earlier in the year. And as long as we'll see how the weight works out, I hope to have Leo's scope collecting photons again soon.
John, that is amazing. You are taking pictures. You are doing astronomy. You are working on astronomy projects. Oh my God.
I'm leaving a trail of tangible evidence of what I've been doing for years.
Wow. Congratulations. It's looking good.
I echo that. Congratulations. Very
Yeah.
good.
So hopefully Leo's scope will be collecting photons in the Sherbet Lake area again soon.
So what's the piece that you're missing, John?
It is the part that goes between the mount and the legs.
Because the legs were never in use before. They were just off to
No.
the side, right? Because the mount was on the concrete pier. Yeah.
So you
Let me-
showed the wedge, the cap.
Yes, the mount was on the pier, so it,
So between that, you had a cap for the pier. Is it
yeah,
between that and the leg?
I'm just trying to get back to my screen sharing here.
Is it like the head of the tripod that holds the legs?
Yes.
Oh, okay.
So we have, somehow we go from this piece
Yes.
to the legs. There is nothing that we can attach the legs to at the moment.
So you've got a different tripod to try out though, right?
Yes, I have
Yeah.
an Opitron 45, which is going, the C14 is going to max that out very quickly. I have not actually been able to weigh the telescope yet, but my online research says it's close to 55 or 60 pounds.
No, come on. You can weigh it just like you weigh a cat. You pick it up in your arms, get on the
Yep.
scale, look at the number, put it down, get on the scale, look at the number, do some math and go, oh my God, I'm heavy. Yeah.
And that involves me spending a half hour digging it out of its storage spot in the basement, which will be happening soon.
So do we want the piece that goes on top of the legs, or are we satisfied with another approach?
Well, if the center wants to do something with this someday, they're not taking my mount without paying me for it.
Got that.
Doug, you can make something, can't you?
Well, yeah, that's what I'm wondering.
Yeah.
Yeah, so we, like I say, we have these.
Okay.
So I'm sure we can find a base somewhere to take a picture of it and work from.
Or we may
Yeah,
find,
If
may
somebody
find a
wants,
used Celestron tripod too,
Yeah.
which would be the easiest way.
Just go on
we
Google
not-
and ask about the wedge and ask for the image, and there'll be hundreds of images.
Can we not take a picture of the LX200? Would it not be the same type of setup?
No.
Uh,
The LX200 uses a single single bars for each leg, whereas the Celestron used as like a crutch for each leg.
Anyway, guess something to consider for another day.
yeah, since there was some
Pure
discussion,
base.
there were a few questions earlier on the chat list about this, so I thought I'd take the opportunity to get everybody back up to speed.
Not on the chat list, so.
Well,
Well,
we could
Doug,
remedy
you need
that.
to join.
yeah. And the new mount is also computer controlled, so that would ease up some stuff on Leo's too. That we wouldn't have to be doing everything by hand.
Yeah, well, that Bayer's drive is a good quality drive, so
Yes,
Even with
There's
duct
no
tape.
doubt about that.
Well, let's
I
keep
would-
working on it because that's a great scope.
I would say that the pier base that Leo had for his post or for the pier has probably been machined to accommodate that cylinder that he had mounted underneath it. So you may not be there. Yeah, that silver part looks like it's been machined to fit. So it might be, that's why you don't, you can't find it.
I wonder if it was there somewhere when we picked everything else up and we just missed it because we weren't thinking about it.
Yeah,
That is possible. Denise never did come across it and give us a call about it. So
Right.
So
Oh,
does
it-
anybody need measurements for whatever they want to look at and do? Is it possible to put measurements on the chat list?
Or we just wait until spring and
Yeah.
see how far along things have gotten.
Mhm.
You'd have to be on site in person, I think, to judge anything at all.
well,
Yeah.
the bits and pieces, if somebody has the time and know how to do this, we can certainly arrange a transfer of like the wedge and the legs or something, if that would be of any help. And I can certainly take any measurements that are required.
Okay, well, something to keep discussing.
Yeah, I mean,
That
I
is
didn't want
for
to start
sure.
anything, but just if
Way to go.
we need
Got it.
something made for it, that's a possibility.
Yeah.
Well,
if
you've
the cen-
started it now, Doug.
if the like I say, once the center finds a permanent home for this place, this wonderful piece of equipment, we'll need to sort that out.
Yep.
In the meantime, I'm hoping to start collecting photons and posting pictures with the new camera I purchased earlier.
Sounds good. Thanks a lot, John.
right.
It's a great update.
Thank you.
Okay, I see that.
Everyone see this is what that base will look like. What he has. What he mounts that other plate onto, this is what it'll look like.
Hands.
As the forks comes up here and that pod sits on here.
okay.
Okay?
Yep, that's the type of thing we're looking for, is something like that.
Yeah, that is what size did you have? 8-inch across that?
I believe
Yeah,
that's what it is.
Yeah, well, that's what that is.
Yeah.
That's a Celestron mount. But this is what you're looking for here. Okay, because even though I have a mono leg, these come out and you can put that crutch leg on there. Okay, so this is the piece that you're looking for.
But
And
can you
then-
sandcast that, Doug, and make one?
How about we just go and buy one on the used market someplace, a whole set of tripod and
There-
connector.
I think there was a mount on Canada Telescope Buy and Sell. I think there was one like that on there. Okay, so do you understand what you're looking for there?
Yep, that looks good. Okay, so I guess we can just also look on the Astro Buy and Sell and see if we just want to get a new mount instead of possibly using what you've got there, John.
The new tripod.
Yeah.
He's got them out,
Yeah.
right?
Yeah.
Just a tripod, not the whole mount and wedge.
Yeah.
Like for myself, I went with the bought a new computerized tripod, but I'm also planning eventually to put my 10-inch meat on it. So
It
no
weighs
matter
much
what
less,
happens,
right?
which weighs much less. So when the center does want their scope back, I still can use my equipment.
Yeah, I'm a little worried that it's that heavy when I don't want it to, wreck the motors in your mount.
That I'm going to definitely, as Kevin says, try to get on the scale with it and see how it works out. I'm not sure the bathroom scales are going to go up high enough but we'll figure out something. I may be able to balance that scope on it by itself and get something close.
That's good. Excellent. Okay, thank you. Okay, next up, we have Bruce Elliott is here, and he was going to give us a bit of an update on outreach. Bruce? Unmute.
Okay,
There you go.
can everybody hear?
Mhm.
So, good. So, yeah, so good evening, everybody. So there's, I guess, two things I wanted to give a little update on. One is the science fair. And the science fair is going to be on the 30th and 31st of March. This will be the final day. It's going to be in person, although, as I think I mentioned before, they're also considering having some hybrid sessions because one of the nice things about COVID, I guess, if there is anything, is that it sort of forced people to sort of, become more virtual, and that meant that people could chime in from out quite far out. So we had people from up around. I'm sorry, I can't remember the name of the town, but there's some towns up north, which had some youth signing in and participating. I think the main part of it is going to be in person, and we'll be recruiting for judging, and I'll be keeping in touch. I'll let you know as soon as there's more information. So that's the main thing, and I think that we had some really good, really very successful winners that in participation in the astronomy aspect. So we had one student, for example, from the Kingston Christian School, and we had another one from the KSS, Kingston Secondary School, so Kingston Secondary School is public. The Kingston Christian School is private, but in both cases, in the last 2 years, we had some, really the teachers of the class, the teacher of the class of the awardee, communicated with us, and we provided some information, some online stuff for them. So that was really good. Okay, so the second thing is Science Rendezvous, and this year it's going to be on May the 13th, and it's also going to be in person, but again they will be having some. They're going to have some podcasts which will be virtual, because, as I mentioned earlier, Science Rendezvous also had a huge number of people from way outside, some people coming in from almost across Canada, from coast to coast. It was really a huge participation, apparently, from more than they've ever had before. So they're really excited about that. I guess so we're invited, of course, to offer the same thing we did before, but encouraged also to think outside the box a bit. And if there's something else that comes up that people want to try, that's great, and they really like to hear about it. So I could help people facilitate the communication to try something new if anyone wants to try. But definitely the viewing of the sun was very popular. And I don't know if anyone's here tonight that actually was on the. Definitely, I'm sure Kevin and Kim were on board with that, but there's other people as well, like Hank, for example, and Lori, and they made some really, they just had a very good way of interacting with the kids, and I think it was all very exciting. So yeah, so if there's any, if anyone has any suggestions that they'd like to offer to or concerns about how something might be done better, then you can contact them directly, Linda Kogan, or I would be happy to facilitate an interaction there. So, but that's basically what I wanted to share tonight.
Okay, that's great, Bruce. Thanks a lot. Yeah, it's going to be a busy year next year, that's for sure.
Yeah.
And with everything looking like it's going to get back to semi-normal, and more in person.
The public health KFLA site looks pretty clean right now as far as COVID's concerned. So
Yeah.
very reassuring, certainly from the point of view of hospitalizations.
Yeah. Everybody stay out of the hospital. Okay, great. So next up, Kevin Cal, going to speak to us on updates of images for 2022 year in review.
Oh, that's me. This is a reminder. This is a project I started a couple of years ago, and I'm hoping to turn it over to somebody, maybe our editor once he gets settled in. But this is the last year's second annual RASC Kingston Centre 2022 member image gallery, where you, the member, submit your best imagery of the year, one single thing. And this is just, you see these in Facebook, you see them in the chat list, you see them everywhere, but they don't really last. And I'm looking at this from a historical angle where we've published something, we'll have that going forward in time. And this is just to give you a quick review of what it looked like. I'm requesting a single image, the best one that you think you have, your name, a paragraph about why you think it's the best image or why you wanted to submit it to here, and then a paragraph of technical details, because everybody wants to know technical details. And we had some phenomenal stuff, and it was just amazing to see. We had 12 submissions last year. I think we had fewer the year before that. I would love to see more submissions this year. Guys, go out and do anything you want. Look, John Hurley took a photo. He has an image. He can send that in this year. Hank Bartlett. Kim Hay. Kim has now got a bigger camera so she can show full disc solar. Ooh. Bruce Elliott. Bruce does some fantastic, what am I going to call these? Wide field landscape stuff. Mainly because I think he goes to that little snug harbor resort and just has a great old time. Rick Wagner, deep sky. Oh my God, Rick, try something different for a change. Something less spectacular than the Helix Nebula. Malcolm Park. I wonder if we should make Malcolm actually go outside and take these by hand. He's got so much automation behind him these days. Awesome comet, awesome. Rosebery, again, great landscape, wide field stuff. And me, planetary, that's what I do. And oh, we only had 11 submissions this time. So the deadline for this year is somewhere around the end of the calendar year. I don't remember what I said in the newsletter in the past. Send them in to me, Kevin at starlightcascade.ca, or Kingston at RASC.ca if you can't remember me. And I'll start putting it together in early January and try to get it published and out the door. And I think that's about all I've got to say about that.
Excuse me.
Okay, thank you,
Kevin, I'm just
Malcolm.
wondering, is the, so.
I have a point of order, Kim.
Yep, go ahead, Malcolm.
Kevin, I took that from outdoors in my backyard. Thank you.
There you go. Congratulations. That's amazing. Okay. Bruce, what was your question?
Okay, Bruce.
Sorry, I guess I look at her. So I just want, so there were the regular submissions once a month, and then is this something different then, which is just at the end of December?
This is an annual publication of what you submit directly for this purpose only, as to put into a historical document. And what goes into Regulus is totally separate. I don't even look at those. This is what you will send specifically for this publication.
So we send in, and we can send in one image then, right? Let's see. Okay, good. Okay, fine. That's great. Thanks.
Yeah, just a reminder, because hey, it's only how many days to Christmas, folks? 10, 11. How many to the end of the year? Not that much more.
I'll do it.
All right. Excellent. Thank you, Kevin. Okay, next up is Rick Wagner, Kingston Centre member and Ottawa Centre member. He's also in charge of the science in behind the RASC remote telescope, and he's going to tell us all about it. You're up, Rick.
And a warning to everybody, Rick's got low internet, so he's turned his video off to get better audio. And when he shares things, it'll take a little bit of time to appear on your screen, and sometimes he'll be talking in front of it, but that's okay.
I'll try and control myself.
Move your mouse slowly across the image. Yeah.
Participants can now see your application. Okay, so thank you, Kim. Good evening, everybody. I wanted to give you a little talk on the remote telescope that the RASC has and what we're doing in the science department with it. So this is the actual telescope itself. This is a 16-inch, 40-centimeter Ritchie-Chrétien Cassegrainian telescope, an RCOS brand carbon fiber tube. So Paramount ME. The camera is an SBIG STX 16803 camera. That's quite a nice camera, 4096 by 4096 pixels, 37 millimeters square. The camera has a small guider chip offset to one side, so you can use that to guide on stars and get better tracking. There's a filter wheel with LRGB, hydrogen alpha O3, and sulfur 2 filters. And the scope also has a rotator to help with framing images. However, we never use the rotator for the science images. We tend not to do any guiding. The unit also has an adaptive optics system for higher speed guiding to try and guide out the worst of the seeing. So additionally, you can see on the top left, just peeking above the scope, there's an Astro modified Canon 6D full frame DSLR with a 200 millimeter f2.8 lens piggybacked on the scope. And there are 2 computers on the floor nearby that run everything. We log into the computers using VNC to run everything. The software, the SkyX controls the telescope and the camera. And then we can either use CCD Autopilot or CCD Commander to script all-night observing sessions, Focus Max for autofocus, and Backyard EOS to control the Canon DSLR. Here's another view of the scope. You can see it's a little dusty. I'll talk about that more. And this is the back end. So going from right to left, there's the camera, filter wheel, adaptive optics, rotator, and then the scope. Lots of wires hanging off it. There's lots of stuff here. So 0.4 meter, f8.9, I didn't mention that, 3,550 millimeter focal length on a Paramount ME, 9 micron pixels in the camera. So it gives us a 36 by 36 arc minute field of view at just over half an arc second per pixel. gain and read noise in case you're really into the technical specs. And the AOX adaptive optics, the 7-position filter wheel takes 50mm round filters, LRGB HA 03S2, and the image rotator. And just to give you an idea of the size of the field, here's the Triangulum Galaxy M33. The large square in the middle is the main chip. So you can see we can almost get the whole galaxy in, and it's one of the largest galaxies in the sky, of course. And then there's the 2 rings around the outside, and over to the left, there's a little rectangle. That little rectangle is the guide camera. And you can see we've got the thing set up so that there's a reasonably bright star on the guide camera. So they say in real estate that what matters is location, location, location. Well, of course, that can have a big impact in astronomy as well. Our telescope's located at Sierra Remote Observatories in the Sierra Nevada mountains, overlooking Fresno, California, close to the town of Aubrey. And we're in Building 9. So here's an overview of the site. You can see there's a bunch of small buildings in the foreground. Those are private observatories. And then the 4 large buildings in the back are the community buildings with multiple telescopes in each one. Here's a view looking down into the first 2 of the buildings. The one on the right is ours, and our scope is in the far back left of that building. You can see there's snow on the ground in California. This is very upsetting when I'm hoping to go skiing and we have no snow, and they do have snow in California. So the benefits of location. This is a typical forecast for my observatory. And in case it isn't obvious, or if you're not a user of clear skies or clear outside rather, the red and orange parts are not suitable for observing. So the little green patches in there are when I can observe here at home. In California, this is not an untypical forecast. 24 hours a day for a week of perfect observing conditions. So far this year, we've had about 90% of the science nights have been clear. Seeing is monitored by 2 cameras, and the seeing is often below 2 arc seconds and frequently hovers around about an arc second. There are lots of other scopes hosted in the 2 buildings, 4 buildings now. I don't know, well, I do know about you guys. The 16 inch is a pretty darn big telescope. Well, not at SRO. This is, I think, a 24-inch. There's some 28 inches. 20s, 24s are definitely a dime a dozen. They recently upgraded the internet, maybe 6 months ago or something, to a fiber. So now I can image all night, create a 600 megabyte zip file of all the images and calibration frames, upload it from SRO to a Google Drive in about 20 seconds, and then spend an hour or more downloading it to my computer at home. Now, of course, there are some downsides to the location. Here's a big scope. You know you got a big scope when you need a crane to lift it on and off the mount. Seeing. So the darkness, dark moon, about 21st magnitude on the sky quality meters. That's about 12 ADUs per second if you're measuring. 119 degrees west longitude, 37 degrees north. So it's fairly well further south than we are, and at an altitude of 1,400 meters, which is what explains the snow in California. So the bad side of the location, this was, I think, 2 summers ago or a year and a half ago. They had one of the worst fire seasons they've ever had in California, and the fires came up within a few hundred meters of the observing site. This is the smoke blowing through the area, and this is what the sky looked like on their all-sky camera. Muddy brown. It's also rather dry and dusty there, so equipment does tend to collect some dust, but there are staff on full-time at SRO, and they'll clean things as necessary. And of course, the other issue common to all remote telescopes, except that in this case, it's a 3,000 or 4,000 kilometer remote scope, is it's hard to get to if you need to do any fixes or adjustments. However, again, the SRO staff is very well qualified, and they can do pretty much anything we need to have done. So, of course, I'm interested in the science side of things, but unfortunately, the majority of people who want to use the scope are the pretty picture crowd. And this is one of the reasons I'm doing this talk. I'm hoping we can start to outnumber the pretty picture crowd. So what it means is that they get 4 nights per week on the telescope to take their pretty pictures. And they do take some wonderful pictures. Here's the Lagoon Nebula by Stuart Hagee. This is the Galaxy M33 by Guy Spence. And you can see that lots of individual stars in the galaxy and the H2 regions all stand out quite spectacularly. Open clusters, OB associations. This is M77 by Dan Meek. Lots of amazing detail. And finally, the Elephant Trunk Nebula by Jeff Dutton in the Hubble palette narrowband image. So to get back to, first I should mention, there's also outreach. Samantha Jewett at National runs the outreach sessions on Wednesday nights every week. She's working mostly on observing exoplanets with high school students. The science team gets Monday and Friday nights, and that sounds like not a whole lot, but in an area with 300 clear nights per year, we've had, I think, about 90 clear nights in the past year. The other limitation that I'll get to in more detail later is that the filter wheel is fully populated with pretty picture filters. And this is a bit of a limitation for some of the science imaging. So for photometry, we use what's called aperture photometry. In the old days, you used a photomultiplier tube and you had to stick a little mechanical aperture in front. Oops. One of my slides is disappeared. So you had to stick a little aperture so that only the light from the star you were interested in made it to the photomultiplier tube. So nowadays we do what's called aperture photometry digitally. So in this case, you can see the red circles in the middle. The smallest circle isolates the light from the star. We sum all the total number of counts, ADUs, that the star presents inside that little circle. But then, of course, inside that little circle, we've also got sky background, light pollution, and so forth that we need to subtract off. So we put the annulus around the outside that gives us a measure of what the sky background looks like. And then we can use that to subtract the sky off the aperture. So one of the problems we have, this is a table or a graph I did some years ago when I was shopping for a new camera. You can see that this is the spectral response of a bunch of different cameras. Some of them are, some of them have much higher spectral response quantum efficiency than others. The CAF 3200 ME is a particularly excellent camera. Its peak response is sort of in the red. Same thing for the CAF 6303, the ST2000 XM. You can see peaks far more up into the blue and green. So why is that important to us? Well, here's a pair of filters. These are both supposedly photometric filters, Johnson Cousins UBVRI system filters. These are blue filters, but you can see there's quite a distinct difference between the two. One is slightly displaced to the right from the other one, and you might not think that's very important until we look at two stars that have slightly different, well, significantly different temperatures. So the yellow line is the spectrum of a star that's got a surface temperature of about 5,500 Kelvin. And the green line is a star that has a temperature of 7,500 Kelvin. And you can see for the right-hand filter, the two stars are going to measure out as almost the same brightness. Whereas the left-hand filter, the green line, is well above the yellow line, almost across the entire width of the filter pass. So it's going to show the green line as a much brighter star than the 5500K star. So what that means basically is that we have to transform our magnitudes. What we do is we measure standard fields. These are star fields that have been measured very carefully by professionals, often dozens and dozens of measures through telescopes, professional scopes, and on absolute perfect photometric nights. And what we do is we take a bunch of images, and we have to throw in a couple of equations, but basically this shows us that the apparent color of a star depends on transformation constants, and then the color of the star affects the final magnitude that we measure. So because we can't use proper science photometric filters, often what we do is we shoot with the luminance filter, and then we use all our comparison stars as visual magnitudes, V magnitudes. This is actually a green filter, which somewhat mimics the view through your eye. So they call it a visual filter. And this is, so using the luminance filter and V magnitudes is quite a common thing. This is particularly good if your main interest is in timing things like finding the period of an eclipse of a star oscillation. If you're trying to find the time of minimum, for instance, of an eclipsing binary or something. Other things, rotation periods of asteroids. There's a lot of things that can be done with just a luminance filter. And the trouble is, though, is that anytime you want to compare your magnitudes with other people to try and build up a longer term light curve, you really need to use the standard filters. So one of the things I did was a bunch of images of M67, which is one of these very well measured standard fields, and took pictures of it in the red, green, and blue pretty picture filters, and then calculated the transforms. And it turns out that we can get fairly reasonable measurements of the B, V, and R magnitudes according to the photometric standards. So that's a good thing. The B magnitudes are not great, but the V and R are fairly good. We would do better with proper scientific filters, but we're not going to get those anytime soon. So the other thing that's a concern when you're measuring the brightness of a star, you can't let the star saturate. Essentially, once a pixel has accepted all the photons it's capable of holding, it stops responding to light. And so increasing the exposure any longer, you're not collecting any more light in that pixel, which means your magnitudes are going to be wrong. So I shot about a dozen pictures or so of M67 again in each of the LRGB filters and measured the magnitude and time that gives rise to saturation. So you can see in this table, for instance, a 10-second exposure through the luminance filter, an 8.8 magnitude. Anything brighter than 8.8 magnitudes is going to saturate on the camera. So we can use that to make sure that we don't get into saturation. Then the other thing we want to know when we're doing science imaging is what kind of a signal to noise ratio are we going to get? The signal to noise ratio basically tells us how accurate measurement we can get from the data. And it's approximately equal to 1 over the error in the magnitude. So for instance, a signal to noise ratio of 100 gives you an accuracy of roughly 1/100th of a magnitude in your target stars. So here's a table, and you can see these are the exposures that are required for various magnitudes. The exposure and the magnitude then gives you the signal to, an estimate of the signal to noise ratio that you'll get. So you can see at the bottom left, the table is empty. That's because basically the signal to noise ratio is so low there that it's essentially useless. And then the top right corner is all highlighted in yellow. And that's because there you're probably going to be getting into saturation, which you also don't want to do. And so if you want to take exposures in that range, you're going to have to mess around to make sure that you don't get saturation, like defocusing or something. Another thing I did very early on was took a bunch of images of some minor planets, did the astrometry, so that's measuring their positions on the sky very accurately, and we submit that to the Minor Planet Center. And when they've reviewed the observations and decide they're of sufficient accuracy, they responded and gave us an observatory code. So now we are capable of doing actual astrometry on comets, minor planets, trans-Neptunian objects, things like that, and submitting them for publication with the Minor Planet Center. So the scope has some limitations. It's only, we can only observe every 3 to 4 days. So if you're looking for something that's sort of changing on about that time scale or a little bit shorter, it's going to be very difficult to figure things out. We don't have proper photometric filters. It's only a 16-inch telescope, so we're limited to magnitudes brighter than about 20. On the other hand, it's also a huge 16-inch telescope, so we're limited to magnitudes fainter than about 6 for realistic work. Images binned 2x2 take about 16.6 seconds to download. So you don't want to be trying to do anything that takes place at a, on sort of seconds time scales. Otherwise, you're spending all your time downloading and very little time imaging. And finally, I mentioned that we don't guide just because it means that we don't have to deal with rotating the camera and stuff. The tracking is very good, but it's not perfect. So stars in exposures over about a couple of minutes tend to be somewhat oval. So in an attempt to encourage interest in the scope, I tried to come up with as many project ideas as I could, covering as broad an area of astronomy as possible. So the first one is astrometry. So again, this is very accurately measuring the positions of objects on the sky so that orbits can be calculated, for instance. Trans-Neptunian objects, these are things like Eris and Pluto and so forth that are in orbits out beyond Neptune. They're very faint, so they're rather challenging, but interesting. Comets, there's always new comets coming along. Not as many as we'd like, perhaps, and not as bright as we'd like, but and minor planets, lots and lots of minor planets. And near-Earth objects. Now, unfortunately, the trans-Neptunian objects and the minor planets are generally pretty well covered. A lot of the automated all-sky surveys now are getting down, some of them getting down fainter than we can go, and doing that every night over much of the sky. So these things are pretty well covered. I've imaged a few minor planets, and almost invariably when I go to the Minor Planet Center and say, you know, where is this thing? They give me a list of positions for where it is at various times, and then say, we don't need any more observations. Thank you. Near-Earth objects, however, do tend to come out of the dark and appear and disappear. And so obviously there aren't good orbits to find for them. A lot of times they're closer to the sun, like in the sky, so more into the twilight sky than the professional observatories are going to look. So these are a potential object for us to image and do astrometry. Of course, the downside on them is that they generally tend to be small, faint, and fast moving, which makes them quite challenging. So another thing we can do is do searches. Minor planets, I remember when I started imaging, discovering minor planets was not all that difficult to do. There was, if you could go down to 15th magnitude or 16th magnitude, you could easily discover minor planets. And supernovae used to be a big thing for some amateurs. However, now, again, the professionals are imaging the sky so densely and so frequently that all the minor planets down to about 20th magnitude, 21st magnitude, anything in a normal orbit has almost certainly been discovered. Supernovae, there are now something like a dozen per night discovered. I think they've got all they need. They don't need us looking for them as well. An interesting thing that I heard about from Doug Welch some years ago is supernova light echoes. So when a supernova goes off, you can sort of think on a cosmological scale as a flashbulb going off, and the light from the supernova streams out in all directions, and it can reflect off clouds of dust and gas. And then those reflections come to Earth sometimes years or even centuries after the supernova. So this would be an interesting thing to look for. Again, quite difficult. They're faint. It requires imaging in the right areas, probably over a period of a couple of years to find them. And another thing that I thought would be kind of interesting might be dwarf galaxies or star streams around other nearby galaxies. I don't know if it's that practical anymore, but it sure gives you a good excuse to take extremely deep images of nearby galaxies. So photometry, of course, is my baby. There's lots of things you can shoot minor planets and trans-Neptunian objects. By doing photometry on a regular basis, you can measure their rotation period. You can, if you do photometry over a long period of time, you can actually contribute to what's called shape modeling. As our view of the minor planet changes over a period of months, you're essentially seeing the planet from different directions. And by doing all the photometry and stuff, then the professionals can do all the math that's required to give a rough shape to the object. Variable stars, of course, there's dozens and dozens of different types of variable stars that we can look at, and anywhere up to hundreds of thousands of examples of each of the types. So there's no limit there. Clusters, both globulars and open clusters. I think it would be interesting to do HR diagrams. These are the Hertzsprung-Russell diagrams that essentially give you a layout of the brightness of the stars against their color. And that's useful for measuring relative distances, ages of cluster, and so forth. And another thing would be variable star searches in clusters. Another one of my particular interests is extragalactic variables. These can be very challenging because even the brightest ones are generally down around 18th, 20th magnitude. And finally, exoplanet transits. This is what Samantha's doing with the high school students. Very interesting to get timing, variations that may indicate additional planets that we don't know about, the existence of moons, and so forth, and just to keep track of the exact orbit timing of some of these exoplanets. Some of them, once they've discovered, they don't get observed for several years, and then we've lost track of exactly when the eclipses are occurring. So one thing we're going to do, we're just working up, trying to figure out how to do this, is we want to run a small number of national projects, essentially, that would be run by the science team as a whole. The idea is that it would promote the telescope, demonstrate its science capabilities, and perhaps more importantly, allow us on the science team to develop our procedures for asking for observing proposals, how the imaging gets done and organized, data analysis and publication, and so forth. And that way, when it comes time for you people to submit proposals and work with the science team, we'll be able to run things more efficiently. So some interesting science results to date. We measured, we did photometry on supernovae in M61 and NGC 3463. I've done some imaging of V619 in the Andromeda Galaxy. This, of course, was the first extragalactic Cepheid ever discovered by Hubble a century ago next year. We've done some HADS light curves, high amplitude delta Scutis. I observe these a lot myself. They're very nice because they have a period of a couple of hours. And also cataclysmic variable light curves. So here's M61 with its supernova marked. Was a nice one. Here's a view of M31. This is a 10 400 second exposures. So effectively a 4,000 second exposure of one edge of the galaxy. And if we zoom in a little bit, you can see marked by the black lines, that's V619 that Hubble discovered. And you can see it shows up fairly nicely. Originally, I was interested in imaging just to see if I could detect it. And once I detected it, I realized I was actually getting enough signal that I could actually do photometry. And now, so we've done a little bit of this star with the remote telescope, and I've started doing some initial imaging of M33 to see if we can pull out some Cepheids there as well. And so here's 6 measurements we did of V619. And with a bit of imagination, you can sort of see the light curve in the red little diamonds going from a maximum at around 18.6 or 7 on the left-hand side, slowly down to a minimum, slightly below 20th magnitude, and then a fairly steep rise up to maximum again. So it's clearly useful information there. And the other thing I discovered with a little bit of digging, we can actually detect novae in the Andromeda Galaxy. This is AT 2020 YPU, which was about a 21st magnitude nova. I don't think we'd be able to discover these things, but we can detect them once we know they're there. This is HP Librae, is a cataclysmic variable star. So this is a normal star orbiting a white dwarf. The white dwarf is sucking material off the regular star into an accretion disk, which then starts to oscillate and precess and gets brighter and fainter. They're very complicated stars with all kinds of different features. And when I first did this photometry and plotted it up, and I thought, wow, that's a mess. Look, it's like we're getting scatter here of about 0.05 magnitudes and just this sort of gentle curve. Fortunately, I connected all the dots together with lines and discovered that what we're getting is actually a really nice view of its period, about 18.9 minutes. So this is actually the disk. I think this is the disk around the white dwarf that's oscillating and precessing with a 19-minute period. And we've submitted several thousand of these observations to the AAVSO and to the Center for Backyard Astrophysics, Joe Patterson at Columbia University. The high amplitude delta Scuti stars, these are main sequence stars, so they're burning hydrogen in their cores. They're generally somewhere around twice the mass of the sun, and they pulsate by the same mechanism that drives the RR Lyrae and the Cepheid stars. So they're very interesting. They're smaller and denser than either of the other two types of pulsators, so they pulsate a lot more quickly, usually around a couple of hours. Here's 3 nights of data, all phased together. You can see the different nights of data all overlap very nicely, beautifully smooth light curve, steep rise to maximum followed by a slow decline. The green dots across the middle, that's a check star, it's called, and we measure that just to make sure that there's nothing going wrong with our photometry. For instance, if our comparison star was varying, then the check star would also show variation. So here's another high amplitude delta Scuti. This is a string of about 8 hours of observing, and you can see that each maximum is quite significantly different than the others. And what this indicates is that this star is actually undergoing 2 different modes. So it's doing the fundamental pulsation where the outer layers of the star are rising and falling as a whole. And then it's also doing pulsations where the outer layers of the star are separated into 2 layers. The outer layer and the inner layer are moving in opposite directions. And all this is happening while it's pulsating in the fundamental mode. So this is quite kind of a difficult thing to get your head around. But what's particularly interesting about this is the exact frequency of the 2 modes and their amplitudes relative to each other and so forth is very, very much dependent on the interior of the star. And so one of the projects I'm working on with Joyce Guzik and Karen Kinamuchi in the US, one at Los Alamos National Labs, is modeling of these types of stars. And by running the computer models and comparing how the model pulsates with my data, we can get a better idea of what's actually going on inside the star. So the goals of the scope, in reach, I think this is a facility that hopefully will be of interest and benefit to a large fraction of the membership. Even those who aren't interested in using it, I'm hoping they will be able to learn from what we're doing and how we do it and what results we get. We intend that this should be a learning experience. The members of the team, the people who work on any of the observing projects should learn how to plan an observing project, plan and execute their data collection, analyze the data and publish or otherwise make available the results. And of course, those hopefully those results will be educational for the rest of the membership as well. I hope we will be able to advance the science of astronomy, publish results in Sky News, the JRASC, and perhaps in some refereed journals. And finally, and unfortunately, we do have to talk about money. This is a fairly expensive facility to run. So we need to be able to contribute to the financial viability of the scope. If there isn't enough income from it, it may get shut down in the future. I always, whenever I'm talking to National Council, the National Board, I always try to make it clear to them that it doesn't have to be profitable. This is a perk, a benefit to membership, and as long as the costs are reasonable, it doesn't have to be a monetary profit. So administration, again, we're still working this through. We have the science team. There's, I think, about 5 of us on the team. Unfortunately, I'm mostly the only really active one. But anyway, we're going to have the idea that we're coming up with right now is that we will have observing proposals. Each proposal would be led by a project lead, and then the project lead would either bring people with them as members of his or her team, and they would do help with the planning, analysis, publication, and so forth. Or the project lead can come in and ask for assistance from the science team in all that additional work. How to join the science team once we stand it up and get it running, I'm hoping it will essentially consist of asking that you would like to be on the team. The submission of proposals. I've done a lot of reviewing of the proposal assessment for professional observatories, and we're coming up with something similar that I think it looks quite daunting at the moment. However, as I said before, I expect this to be an educational process. So at least at the beginning, particularly at the beginning, I anticipate that this will be a two-way process. Somebody can approach us with an idea and then we'll hash it out, help with figuring out what's possible, what the observing program might be, et cetera, and so forth and so on. And we haven't really assessed the fees yet, but we're thinking that the project lead would pay, say, a monthly fee for the duration that they're using the telescope for their observations. So, any other points I want to make? I think that's about it. So I encourage you to watch what we're doing. We do try and put out a little note in the bulletin every quarter or so. Each of the observing teams on the remote scope is supposed to do this every 3 months. And so I try to present some of the scientific results and so forth. And I expect that probably come spring, we'll have the science team up and running. So are there any questions?
Thank you, Rick. I've got questions, but I'm waiting for Malcolm to ask his.
Did you know my hand was up?
I can see your hand up.
Okay, just one question with a add-on. Is the scope, what's the focal ratio of the scope, and is there a reducer on it?
It's f8.9 and there's no reducer.
Thank you.
I thought there was a follow-up. No? Okay. Thanks, Rick. This is Kevin. I really appreciate you bringing up the financial side of things. I've been a proponent pushing for RASC to get a remote telescope for like 20 years, but unfortunately, I think the way the realization of this came was not the right one. And I'm looking at the finances, and oh my God, I really hate to say it is so expensive. $24,000 in 2020 and $33,000 in 2021. I'm a little afraid to see what 2022 will be. And what about your thoughts on, do you think there are other alternatives perhaps that are cheaper to operate? I mean, we're not even talking buying capital equipment. We're just talking operational costs, aren't we?
Yeah. I think they're talking about $1,500 a month. Which I don't think, I don't think you're going to find a remote scope for anything less than that. I was looking at a point at New Mexico skies, and it was going to be $30,000 to $40,000 a year.
Holy
American.
cow. I mean, let's just give John Hurley $1,000 and say, John, get Leo's telescope up and running in your backyard remotely.
Well, if John is foolish enough to accept that, but I think it would be worth a lot more than $1,000 to.
Yeah, it's tough to say. Our expenses seem to be running without limit at all in the organization, and this may be an easy cherry pick to say. Now, we purchased this outright, right? So it's actually got a capital value.
Yes.
If we were to sell
We
it.
got, I think, a fairly substantial reduction because it was used.
Yeah.
I knew.
Because I'm just thinking of Dave Lane's mini Ralph project that he built together as a little remote observatory test bed. And I still love that concept, and I wish we could do something like that, again, as a test bed to see, okay, we've done this, now we can do something bigger. And I'm pretty sure that its operational cost would be much smaller order of magnitude.
Well, it's hard to say. I mean, you have to consider the fact that this is a large telescope with a large camera on it, very good mount. It's at a stunning site. I doubt if you would find a site in Canada as good as that. So, if you're going to pay a quarter as much, you're probably going to get a quarter as much telescope.
Thanks.
So-
I can see that some of the budget can be allocated off to other public outreach and education budget line items and things like that. I think the more communication you can have, the more reporting you can do through multiple channels, the better. I rarely even read the bulletin anymore because it's not in paper. It doesn't come to me. It's not in front of me when places that I prefer to read. And so I don't read it a lot. And every avenue of communication would be a great thing. I mean,
I think you have to consider the value of having such a well-trained group of people who are actually employed on the site, looking after all of that other equipment. Like it's very difficult to match that kind of expertise when you have all of those different pieces of equipment. And it sounds, Rick, you're under the impression that they're quite responsive to any issues that come up?
Yes.
So, you have to think of the value of that.
Rick, it's Kim.
Yeah.
Samantha was saying something about that she was going to end up going out to California to the scopes, but that we're actually supposed to be getting some new equipment for it. You know anything about that?
Yeah, the computers that are on it right now are getting quite old in the tooth. They're Windows 7. And so they're looking to upgrade the computers. I think they want to do some cleaning and possibly some collimation on the scope. So there's just a few things. The computers, I think it's something that's easier to do yourself. We have a couple of IT guys who run it all for us. And so they're deciding on what the computers are going to be and the software and so forth, just to keep control on the systems. So we could probably ship them down and the guys there would hook them up. But I think there's also a desire to see the equipment, check out and get a better understanding of the position of the scope in the building and so forth. I don't know if you noticed one of the early slides, there was a large electroluminescent panel on the wall. And some of the telescopes use those on a nearby wall, and then they can just tip the telescope down and point at it and do all their flats on an electroluminescent panel. As it is now for us, we have to do twilight flats, and because the vignetting in the scope is not exactly symmetrical, if you rotate the camera to get a guide star, you have to rotate the camera to do the flats for it. So if you're doing 3 or 4 different filters at a couple of different orientations in a night, you're trying to get 30 or 40 or 50 flats in fairly short order, in sort of 15 minutes or something at twilight. And so that requires a fair amount of careful management to be able to not use so many rotations and filters and so forth, so that you can, over a series of several nights, you can catch up with the flats you need. And that's why we don't do any flats or rotation for the science team.
Yeah, when Samantha was holding the telescope open house type thing, and she ended up taking some images. Anyway, I went to the directory today, and it's like they're huge files, they're very big files.
Yeah. In fact, what I've started doing is I shoot all 2x2 binned, which reduces the file sizes by a factor of 4. And then for most of the targets, I only shoot the central half of the frame, which reduces it by another factor of 4. And I still end up having to download zip files of 600 to 700 megabytes after every observing session. We've shot, I didn't mention, so far this year, I think we've just shy of 16,000 images so far this year. So we're keeping the scope busy.
Now, is that everything, or is that just photometry?
No, that's just the science team.
Just the science team.
Yeah.
Yeah. Okay.
And yeah, it would be almost exclusively photometry.
So is there a full listing of stars that you do that if we wanted to go into the AVSO database to see what they were? What would we look for? What code would we look for?
I don't know if you can. A lot of the data I haven't submitted.
Okay.
But what I try to do, and I usually remember, is there's a comment field at the end of every report, and I put in RASC remote telescope in there. So I don't know if you can search on the comments or not.
Might be able to.
Yeah.
Yeah. Okay. Well, you get yourself a glass of water and have a drink because you're up next again for the what's up in the month, so you might want to drink.
Yeah, well, it's a little ways to any water.
Oh.
Yeah.
Okay.
All right,
well,
so I'll continue on then.
yes, definitely.
Oh, I did that the wrong way. Turn off my video, Kevin.
Okie dokie. Let's see here. Richard Wagner. Stop video. You're good.
There we are. Thank you very much. All right. So the sky this month, December, end of the year. Local events. I couldn't find any. We'll just have to stay home. BAA events. Oh, nothing. I don't think there's even any in-person events for the BAA for the rest of this year. I did happen to sit in on much of the Christmas meeting on the 10th of December, and it was excellent. I wish we had their guy doing our sky this month because he's a lot better than the guy we got. AVSO webinars, none again. So they're going to start up a new program, presumably in January. So hopefully things will start showing up again. Lennox and Addington Deep Sky Viewing Area, no scheduled events, but it is, of course, open through the winter. North Frontenac Deep Sky Preserve, no events. God. Hours of darkness. Well, this is one good piece of news. We have lots of hours of darkness. You can see we get up to 11 hours and 38 minutes of astronomical darkness, something like 12 and a half hours of nautical dark or better. 21st of December-ish, of course, is the equinox when the sun is at its lowest altitude at noon, 22 degrees. And we get our longest night. It's interesting that the time of sunset has already reached its latest or earliest rather time at 4:24 in the afternoon. Sunrise is still continuing to get later and will continue to get later up until about the 1st of January. So sky events. Well, we do have some things going on in the sky, fortunately. 16th of December, last quarter moon. On the 21st of December, Mercury at magnitude minus 0.6 will be at its greatest elongation east. So that means it'll be low in the southwest shortly after sunset. I'm not sure whether this is a help. Venus is about 6 degrees below and to the right. So of course, Venus is much lower in the sky, which means it'll be harder to find, but it's much brighter, which makes it somewhat easier to find. So I'm not sure which of these two will be easier to see, but hopefully one will provide a guideline to the other. 21st of December, we have winter solstice at 4:48 in the afternoon. Sun is at its furthest south and begins moving northwards. That means summer is coming eventually. 22nd of December, the Ursid meteor shower peaks. This is peaks rather. This is a very minor shower, best seen in the pre-dawn hours. New moon on the 23rd of December. On the 28th and 29th of December, Venus at magnitude -3.9 is just 1.5 degrees from Mercury, very low in the southwest shortly after sunset. You'll need binoculars probably to see them. And the 30th of December, first quarter moon. And oops, a little bit of an error there. Early January events before our next meeting. 3rd of January, the quadranted meteor shower peaks. This is actually one of the best meteor showers of the year, and doesn't get nearly the press that it should. 4th of January, Earth is at perihelion, so it's as close as it gets to the sun at 147,098,925 kilometers. And on the 6th of January, full moon. So unfortunately, that full moon is going to interfere a lot with the quadranted meteor shower. Small bodies, there's no asteroid occultations worth mentioning this coming month. However, there is a comet 2022 ZTF. ZTF, of course, being the Zwicky Transient facility. That's one of these large telescopes, multimeter telescopes that images much of the sky every night. And so you can see in the morning sky, Corona Borealis and this little comet heading from the bowl of Corona upwards and to the left. So those are positions, I think, every 4 days out through to early January. And it's going to be around 10th to 8th magnitude at that time. And it's possible it may even get up to about 5th magnitude as we get into January. So that'll be exciting. Where am I going? Oh, the end. Does anybody have any questions?
Thank you, Rick. Now there is the Queen's Observatory open house in December.
Oh yes, I missed that one.
So
I
that's
had
coming
trouble
up.
finding it at the end.
And Kevin says we totally missed the BAA event on the weekend. Is it something, where can we put that where people can be reminded of it and find it? Totally missed it.
Well, we could add it to the astronomy calendar, our community calendar.
Did they record it?
Yes, it is available. If you go to the BAA website and click on events,
right,
you can click on the individual event. Then it tells you that it's going to be a live broadcast on our YouTube channel. And when you go over there, it's still there.
Okay.
And I definitely enjoyed it a great deal. It was
Okay,
particularly, there was a lot of really good information on asteroid occultations. About an hour and a half talk on timing asteroid occultations, software, hardware, everything.
I found it.
Excellent. Okay, does anybody have any other questions for Rick? No? Okay.
Thank you.
Thank you, Rick. Hope Jeanette gets home soon. Because that weather does not look nice. Okay, so now we're going to move over to the members observing report. So we'll have a round table. So let us start off at the top of the list with Elena.
Nothing this month.
Nothing this month. Not even birds. Not even. Okay. John Hurley.
Well, a little bit of solar today you saw, but last night on my way home from Kingston at 10:23, there was a very bright meteor shooting down directly in front of me to the north. It was almost pulled over and took a look. But it was a very quick event, but very bright.
That's good. Mark K.
Well, that's Neptune, in case you're wondering.
Don't see anything.
You don't see anything.
No. Do not see the blue dot.
It's not blue because it's a mono camera.
It's right in the middle, right?
It's right in the
I
middle.
can see it.
I don't see it.
All right.
Sorry,
There's
which,
a
Okay.
which planet did you say that was again? Sorry.
Neptune.
Neptune. Okay. Wow.
I saw it before you were spotlighted. I don't know why that is.
So
Yeah, I could see it too.
what magnification do you have on your telescope?
I have no idea.
I mean, well, how big is the lens?
Are you seeing this?
Oh,
Yep.
So that's M77 that I took last night, and I was wondering whether my camera had fogged or the corrector had fogged over, because of course there's that the bright thing in the middle, and then there's that faint thing around the outside. But Rick had some shots of it in his pretty pictures, and that's the way it actually looks. So that's I'm still learning how to use the damn thing. So had a whole bunch of fun last night.
M77 is kind of an interesting thing because I showed pictures a few years ago. And if you take like a 1 minute exposure, all you get is the core of the galaxy, just a little teeny oval. And then you take longer exposures and you get that, sort of the inner arms. And then you take really long exposures and you get the whole galaxy. So it's
That's a 10-second exposure, but it's because it's at f2. So yeah. So anyway, that's pretty much it. I have last night and the night before were the first times I'd been out observing for a long time, because it hasn't really been very clear. So anyway, next person.
Hey, Malcolm.
I'll share my screen if that's okay.
Ooh.
Nice. I did some Geminid wide angle imaging last night, and I got 28 reasonably bright images. I won't show them all, but there's a couple of interesting ones. This one I like when they get that flare in them. And you can see the difference in the, that's well into the morning, pre-dawn. And then this is pre-moonrise. There's a nice one there. And I think there's another one over here somewhere.
When you were outside, right?
For a while. I actually didn't see anything naked eye. There it is. So that's my Geminids experience from last night.
Very good. I liked the little movie you had on Facebook.
Thanks.
That was good. Hey, Susan Gagnon.
Well, I've had 2 or 3. I was just looking for my notes and I can't find them. 2 or 3 nights out, and saw a couple of good Geminids. The one, the fireball that I reported and Kevin found on the all sky camera. And just, yeah, nice to have some clear skies. Nothing exciting, but just, that's it. Oh, and trying to remember to have a look at the planets. I get totally absorbed in something in the eyepiece, and then I forget to just drive around and enjoy the obvious stuff. So I'm trying to remember that. Anyway, that's it.
That's good. Excellent. Brian McCracken.
Yes, I was out taking some pictures of the well, trying to anyway, of the Geminis last night. So I had my camera on the tripod and it was taking about 10-second exposures every 12 seconds. And out of, so that was about, I guess I shot from 7 until about 10:30, and that was about 800 images, which I went through today, and I've captured maybe 4 meteor trails. I stopped too soon, I think, because I see some of the images some of the other folks got were pretty brilliant. But I still have to process them. That was just sort of, takes a little while to go through 800 images, but yeah, I've got some that I'll process. So I'll show that maybe next week.
Excellent. Thank you. Bruce Elliott.
Well, I had some fun. So it just so happened that on the 8th of December, it was a really clear night. It was very cold. And so that is the month of opposition for Mars, the day of opposition for Mars. So I went out and I initially tried to do it just from the house, and there were too many lights. So I walked over to the east further onto another street that was actually totally dark. For some reason, the street lamps had burned out or something. So I just set up my tripod there, and I got some really beautiful pictures of Mars and Taurus, and there were trees. So it was sort of coming through the trees, which was kind of neat. But I thought I wanted to get a whole field. So I then walked down to the Downey Park, which is just near a little, not too far from the time statue. And I found sort of a reasonably dark spot there, and I got a nice full field. And so I'll maybe show it, not tonight, but at some other time. Yeah. So that was I really felt good after that.
Excellent. That's great. Fred Barrett.
All right, got me?
Yeah.
You hear me?
You
Yeah,
betcha.
that's good. Okay, well, I haven't done anything spectacular this month. I go out every night till it's clear, and for half an hour twice with my binoculars, and I just roam around. My observatory still isn't up to scratch. So it was a good month, as far as I'm concerned. Some really spectacular nights over the last 2 weeks or so. Last night was fantastic. I think the night before too. Tonight, not so good. Anyway, that's it for now.
So is it cloudy there now?
I don't know. I haven't been out for about 2 hours.
Hmm.
It was clear when I got home an hour or two before the meeting started. Although there was high cumulus, filtering through. I'll find out. My dog is eyeing me here. She's due for a walk, so I'll know when I take her out for a walk. Grab my binocs, and if it's clear, I'll spend a little time till the cold gets to me.
Okay.
It's not snowing yet, if that's what you mean.
Not yet, no. Okay. Peggy Hurley.
Well, I've been joining John on some of the stuff on the building the observatory, and I haven't checked out the new camera lens yet. I've held it. That's about it. So I'm looking forward to trying it out on the birds too. We've had quite a few of those hanging out, and that's probably about it for me.
Okay, excellent. Doug Engel.
Yeah, nothing for me. I haven't been out observing in some time now.
But you have possession of the scope, so you can.
I can. I do have the scope, and
I
Too
know,
busy
life
with other
gets in the
things.
way.
Too busy with other things.
Yeah,
And we have enough trouble going outside and observing with assembled scopes. You don't want to be
Yes.
outside at -15 putting together
Trying to
metal
push-
tubes. No.
no, no,
I've been there.
yeah,
You just
Okay.
wear about 40 pounds worth of clothing.
yeah, definitely. Okay, great. Thanks for coming tonight. Gerald,
Well, I don't have any photographs. I don't do photography, but I have been enjoying Mars and Jupiter and Orion, especially lately on the clear nights. My balcony here faces due east, well above the city, so I have a city globe a problem, but I'm well up and high enough that it doesn't cause too much grief for the brighter objects.
okay, that's excellent. Okay, Hans. Oh, Hans not there. We'll come back to Hans.
I got it. I
Oh.
got it. Sorry.
Oh, there you are.
Okay. Not much observing as I've been helping a friend of mine build a house in the Burnt Hills area of north of Battersea. But we did manage to get some good pictures of a falcon taking a rabbit right in front of his place. And this morning when we got to the building site, a big snowy owl had taken residence on the open trusses, and he stayed there. He didn't bother moving during the day. He just fell. That's all I got to report.
Wow. Okay. Great wildlife. That's awesome. Okay, Keith.
I have been out a number of times doing a little bit of visual work, but the scene here has been very, very poor. And even during the day, looking at the sun, it was hard to get any clear vision of anything. I did go out last night, and I was actually out yesterday looking at the sun, but the scene was very, very poor. I had to constantly adjust the scope to try and keep the image in the eyepiece. It was constantly going dark and moving, and doing white light was almost impossible. But I did step out around 6 o'clock. It looked like a nice clear sky, but and I did get a chance to visualize Jupiter. I haven't seen it that clear in a long time, so I could see all the cloud bands. I could see 4 moons. One was quite close to the Jupiter. And then I went out a little later on, probably around 7:30, 8 o'clock, to see if I could equally get a good view of Mars. And the weather was terrible. There was so much water in the air. The ice crystals that were forming on the cars was amazing. But I endured. I went out, and I was trying to look through, and I found that every time I put my eyeball close to the eyepiece, the damn eyepiece would fog up. So I would clean it and quickly look. And then after a while, I still couldn't see anything. And then I realized that my main part of the scope had fogged over. I had the dew shield on, but I didn't put the damn heater on. So by that time I was frozen, so I just folded up. But I really get lousy weather here when it comes to, it's been so wet here. Every day you go out, the cars are covered in ice. And I'm not sure if it was Monday or Sunday. Got up in the morning and everything, all the trees, all the bushes are covered in ice. It's all, and the sun is shining through. So just a beautiful crystal thing, but it sucks for viewing. So that was pretty well it for me.
At least you got out. That's good.
I did, yes. And I'll keep going, but it's, unless you go out, you won't see. So you just have to take your shot at it and hope for the best.
That's right.
Kevin here. Can I suggest that you take some pictures of these ice crystals and perhaps we can compare chicken methane ice crystals with regular ice crystals that the rest of us get?
I actually thought of taking a picture because at least I can get the camera that has autofocus and it will be in focus. If I do it manually, doesn't matter what I do, I cannot get the darn picture in focus. And I know it's not the camera, it's me. I've just got ancient eyeballs and they do not work. But I should have done that. It was really nice to see.
Awesome. Thanks for sharing. Okay, next up we have Mark Delorier.
Well, I was out last night, and as Kevin pointed out, at least I could find Mars. So I got that accomplished last night, and then I posted on the chat line a very blurry vision of at least the right color of Mars. And I have my scope out my back deck tonight, so I'm hoping to do better. So I'm hoping to go out there and it's still clear. I'll be pretty ticked off if it's clouded over. So I'll try to do better tonight.
I can see stars at my place.
Oh, so it bodes well for me. So I'm hoping to improve that blurry blob from last night.
Okay, excellent. Mike Haynes.
I got out last night for the first time in 8 weeks, and I was just trying to image the fireworks galaxy, and I haven't even had a chance to look at my data to see if tracking was good. I was just a little bit too busy today to sit down and crunch stuff. So otherwise, I might have some pictures or not had some pictures. But anyway, that was nice to get out, even though it was kind of cold. I bundled up and went outside and opened up the observatory, and everything seemed to work okay after sitting for so long. So it was good news.
Well, it will be snowing for the next few days, so you have time. Yeah. Okay, Rosemarie.
Oh, like a couple others, just doing the looking at the Giminids. And I kind of wimped out. I was going to go out and sit out on the patio, but it was too darn cold. So I set the camera up down at the basement window, the one that I have clear with no plastic on it, and set it up. And like Stephen was saying, you go through a few hundred images trying to pick out the meteors. I got one bright one kind of behind some tree branches, kind of off on the horizon, and got a couple more. When I download them, I'll have to whack them up in Photoshop to clear them up a bit. And while I was standing there, now I woke up here during the night and stoked up the stove and turned the lights off, and I was sitting there in the armchair watching, hoping that I would see a couple bright ones, and sitting there for a few minutes and fell sound asleep in the chair. So, but I did do some, and of course the big wet nose gets me out there. So, I was standing out for a few minutes, with the flashlight off, and she's kind of like tugging to go back in the house because it's cold. But I've got to take a look tomorrow. I've been busy trying to get stuff done before the snow hits and trying to get the firewood, packed away and stuff. So hopefully tomorrow I'll have some time to, the next couple of days, try to have a couple of these by Wednesday to show, a couple of meteors. There's a strange bright light, a little tiny short bit of light going from east to west. And I looked at the frames before and after, and I don't see what the heck is causing this. Like it was an airplane or something. You get, something in the frames before and after. But I want to try and hit that thing and enlarge it and see if we can figure out what the heck that little light is. Because it looks like a little tiny short meteor, but I can't be sure. So, and I haven't had time to play on the computer the last couple of days. So anyway, I'm hoping by Wednesday I'll have 3 or 4 pictures of what I've got so far. And that's about it.
Sounds good. Thank you. Tessa.
She wasn't expecting you.
No, I don't think so. Nice to see you, Tessa. Okay, Richard Wagner.
I'm here.
Anything observing wise?
Yeah, so just riffing off of Mike Haynes, was out last night for the 33rd time in 8 weeks. Just a jab there. Yeah, so I went out, I did, one of the things I've talked about is doing DSLR photometry. And I keep telling people, you can do this. And I've never done it. So, so I'm sitting down. I took a bunch of pictures last night of Algol and Delta Cephei and Polaris, various exposures, various ISO settings. And so I'm going to start running up the software to see if I can see how it's done so I can actually respond to questions in detail. And once I was done that, I stuck the camera out on the south deck, pointed at the sky, and just let it run until it ran out of batteries. And I don't think I caught a single geminid. However, I did go down and sit on the deck, on the dock, for 10 minutes or so and saw 3 from down there. Oh, one of the interesting things about DSLR photometry, I was looking for references on how to do it and stuff, and I found an organization called Variable Stars South, which is the variable star observing side of the Australian amateur astronomers and the Royal Astronomical Society of New Zealand. And so I was looking back through some of their old newsletters and found a picture of myself in the New Zealand newsletter, which was rather bizarre. So what else? Oh, well, I'm observing right now. So I thought I would just share my screen here if I can. We'll see how long it takes for there we go. So this is what my screen looks like while I'm observing. Down in the bottom left corner, this is CCD Commander. So here's the script that I've set up, and I have where am I shooting? I'm shooting KO Piscium right now. So I have run the list named KO Piscium, and under that one, I have moved to the target, plate, solve, sync, and re-slew, just so in case the pointing isn't dead on, it recenters it. Then take, basically just take continuous 300-second B-filtered images, auto-guided. And when KO Piscium gets beyond 2.4 hours beyond the meridian, basically that's when it starts going into the trees. I skip to the end of the sequence, and then I will go on to the next target. And CCD Commander basically uses Maxim to run the camera. So you can see there's the camera control window. That shows how the exposure is going, tells me the temperature of the camera, what its cooler power is set at. Here's a graph of the guiding to see how the auto guiding is going. And this is the last image that was completed. And you can see my target scar is marked with the apertures and the sky background ring, as I was mentioning. And over here in the information window on the right, you can see it gives a magnitude of 11.447. That's rather more accurate than it really probably is. It would require more careful measurements to get an accurate magnitude, but with a signal to noise ratio of about 1800. So I should be able to get photometry down around 1,000th of a magnitude on that star. And basically I just, I let it run, and that's what it does until I notice that it's clouded over and I shut down. Sometimes I get up in the morning and I've got 6 or 7 hours of clouds, but anyway. So that's what I'm observing. This
So
is
that's
this.
the Boltwood?
That's with the Boltwood scope. And for me, this is observing session number 154 this year. My goal is to try and get over 156, which is an average of 3 nights per week. So I think I've got it made. I got another 2 weeks yet to hit the last 2 observing sessions.
No, for 2 weeks.
I smell a jinx.
No, come on, can't be that bad. 2 weeks?
Yeah, next couple, 2-3 days anyway.
Yeah.
Okay, thanks a lot, Rick. Kevin.
Why, yes, I do have a few different disparate items. Let's start with optimize for video. Let's start with Susan's report of a fireball. And this was 2 nights ago in the south, and I guess somebody was outside there. So this is our All Sky 2 camera from the University of Western Ontario. It has been in operation now for over 10 years. I am just in shock and amazement that something works that well. And this is the fireball that Susan saw at 0054 UTC. Quick, convert that to Eastern time, somebody. -5. Come on, you can do it. 1954 Eastern. So one thing that we're going to do is take a look at the actual video. And this is in real time, and it is a 3-second event, start to finish. That's pretty neat, very low in the south. So 2 nights ago, this is the Geminid meteor shower, and we had 39 events listed here. And this is a compilation image of all of them. And the moon going through, some of the brighter stars going through. This is not time synced or anything, so that each meteor, you'd have to do further analysis to find out where they're actually coming from, because the sky is turning constantly. So was anybody out last night looking at Geminids? Wow, 134 events captured. 134, oh my God. And this seems to be one of the bigger ones up here in the north. But that's a very good turnout, and it was clear. Oh my God, was it clear. So we're going to try to find that big one here. The thumbnails are sometimes a curse, and I don't, maybe we'll just have to watch for it here. 0525. This is an animated GIF of the night to help show things, what's going on. 0719. There's some big ones there once in a while. No. How long does it take to go through 139 events?
I did see one bright one sometime after 8 o'clock, but the rest of the time I was kind of glued to the eyepiece.
Yeah. I just want to catch that big one there and see if we can bring up the video on it. Ooh, there was cloud there. Ooh, nasty. Okay, there we go. Before 03. So it looks like very near the start of the cycle. So we should be able to do this. So we're just flipping. There it is. Previous. And let's look at the video of that one. This is a 4-second event. Boom. Very nice. So hopefully we'll get a few more tonight. The results will get uploaded later tomorrow morning. And
Now, Kevin,
yeah, no.
Is this is the software is doing motion detection and stuff like that. This is not like the little ASI 120 home.
Correct. This is a 10-year-old, actually 15-year-old PC Super Circuits low light video camera that goes through a digital converter and does continuous analysis and detects motion according to its own algorithms. And it's only 640 by 480, which is pretty amazing. Yeah, the All Sky 1 is not nearly as reliable, and we've been having issues with that. So the other thing I wanted to show you was, I'll comment on last night's scene. It was poor. and transparency was poor. So anybody out imaging last night, I can understand why your results weren't as good as you thought they should be. Last Friday night was average, and things were much nicer. And this is a demonstration of Jupiter, the best 5%, and Jupiter, the best 10% of the night's runs. I'll just try to make this a little bit bigger here. So this is an animated GIF created from, I can't even remember, 3 or 4 hours worth of taking an image every 3 minutes. And you can see, did I label the names? Not on this one. You can see the great red spot coming on. You can see the great red spot. No, they're not synchronized in time. But the best 5% you would think would be nice and sharp and the most clear in detail and all that. But it also lacks a lot of the signal. So the best 10% over here, you should be able to see that the contrast is better, the cloud definition is better, the great red spot is better. Over here on the left, the great red spot is hardly even noticeable, whereas on the right-hand one is much, much better. So I processed these the same way, the best 5%, the best 10%, and each one of these was about 30,000 frames in total. But I just love the moons disappearing. That's the Io going around behind the moon first, and then Europa coming along to go behind it later on. Okay, and was there anything else I wanted to show here? That's all. That's just a single still image of the Geminids. Today is Wednesday, so this was Tuesday night and this was Monday night. And I think that's everything I wanted to talk about. Thanks.
Okay, thank you. I'm going to share.
You're muted.
I'm going to share.
On the picture.
Okay, this is an image, the same image that John took. Mine's oriented to the, so that the sun east is on the left and south is down, north is up. And if you look at the spot that's on the lower right-hand side, which is 3165, that flared at 1712 UT. I took a picture of H alpha at 1722, 10 minutes later, but I caught the downward side of the flare, and the flare was an M2.2. So it was quite active. And the spot, the group that you see that's on the southeastern side, coming on to the middle of the sun, that was the groups that were actually firing off C-class flares. I think it was yesterday. And there were quite a few of them. And that, I believe, is 3160. Not quite sure which one that is. 3160. Yeah, I'm not even gonna guess at it. So anyway, that was the image that I took today. I do have the H alpha, but apparently it looks a little dark, and I'm not sure why, because I had lightened it up quite a bit. But I did catch the flaring coming down, and that is all I have. Okay. Okay, we have come to the end of our observing reports and our official meeting, and it's 10 after 9 and it's clear out. And I know people want to get outside and do some observing. So I just want to remind everybody of the meeting next month is going to be in person in room 226 in Ellis Hall. But we will be doing a hybrid event. Of course, there could be technical difficulties, so bear with us. And until then, we'll see you on the chat list. We'll see you on the social next Wednesday. Everybody have a safe and happy holiday season. And take care and be safe. And we'll see you in 2023.